So this presentation will be about micro frontends with a very, very difficult spin with multi-versions and multiple frameworks. So I guess you already know what micro frontends are about. They are basically about having a huge front end and you are splitting it into several more or less independent front ends. And you do this first and foremost to be able of assigning individual teams to all of those parts. Teams that can work on their own, teams that don't slow down each other, teams that don't need to coordinate each other. So it's all about team autonomy. And to put it in another way, this is all about bringing back the agility of a small team, even though you have a huge overall software system. The thing is, as you have several independent front ends now, somehow you need to integrate them. Because usually your user is not interested into starting 50 applications each and every morning. Would be a bit exhausting, wouldn't it? So somehow you need to integrate all of those front ends. And you need to do this at runtime. Because everything is developed independently. Everything is deployed independently, so only at runtime you have the newest version, you can pick it up and put it into the middle of what I'm calling a shell, this overarching application. And for loading something into a shell, something we did not know at compile time, something like federation has proven to be very powerful. The idea of federation is quite straightforward. You have two kinds of applications there. You have a host, I call it my shell, and you have a remote, I call it the micro frontend. And then the shell gets a configuration. There is a mapping pointing over to the micro frontend over there. That means you get a virtual URL like mfe1, you see it here, and this URL points over to the micro frontend. And over there, you have something like exposed files, JavaScript files with components, with services, with something else. And everything you are exposing there can be loaded into the shell. All the shell now needs is a dynamic import using the map names, and so it can grab over and load something from there, even though it did not know it at compile time. From the shell's perspective, this is like lazy loading. However, the big difference to traditional lazy loading is that we did not know the stuff over there at compile time. In order to use Webpack Federation, you need, of course, Webpack. But meanwhile, as Webpack is not the most famous tool anymore, it has been ported to RSpec. Honestly, the main further development happens in the RSpec space, and there is also quite a nice WIT board. Besides this, if you are going with ES-Build, you can go with native federation. From your perspective, native federation looks more or less the same. You have the same API surface. However, it is framework independent and bundler independent. It is just using web standards, and so you can port it to each and every stack. ES-Build support is quite important for me, because meanwhile Angular is mainly using ES-Build underneath the covers, and I'm doing a lot of stuff with Angular. And besides this, having something that can be ported to everything else also provides some value. One of the best things about federation is you can share libraries. So let's say you have the same framework here and there. Of course, you don't want to load the same framework 10 times just because of having 10 independent micro frontends. You just want to load it once and then share it at runtime, and this is completely possible with federation. It's just a matter of the configuration, as you see here. The thing is, when we really talk about independent teams, when we talk about team autonomy, we also can end up with a situation where you have different versions of the same framework, or perhaps even different frameworks. Of course, we don't really plan for this. Usually we want to avoid this zoo of frameworks, this zoo of versions. However, it can happen. We have independent teams. Perhaps we had a merger of several companies. Perhaps there are historical reasons why we have more than one framework or version. Or perhaps we need to move over to a new technology stack little by little. Especially in the enterprise environment, where we have long-lasting solutions, this is quite usual, that we need to migrate little by little over to a new stack. We cannot rewrite everything at once. We cannot do a big bang migration. We have to do this in a gradual way. And that means sooner or later, you will be in the space of multiple frameworks or versions. And it's even worse, because chances are that you are using different minor versions. And also there, you might need to go with a multi-version scenario, even though it's just a couple of different minor versions. This is more or less because of how Angular works. If you look into Angular, for instance, and you might also have this issue with other frameworks, then you see that Angular comes with its own compiler. And more other frameworks do the same. And when this compiler is now compiling your source code, then it is emitting code, JavaScript code, low-level JavaScript code, that is bound to your very Angular version. And this binding points to the private API of your Angular version. The private API we as developers are not allowed to use. But the source code emitted by the compiler is allowed to use all those instructions. And as this API is a private one, you have no guarantees in terms of semantic versioning. And that means if this code sees another minor version at runtime, it might break. Very likely it does not break. However, there are no guarantees because we are using the private API service. And I think this shows that you will be in the scenario of multiple versions a bit sooner than you might have expected. So the big question I want to answer here in this presentation is how to implement such scenarios. And for this I have prepared several things. I will get started with hiding frameworks, with abstracting the details of frameworks and versions away. Then we will talk about web components in combination with federation. We will also talk about alternatives, because there are always alternatives with a lot of consequences, positive and negative consequences. And finally, I also want to talk about the costs of all of this, because in this world, nothing is for free, as you know. Before we get started, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of companies. I'm traveling around. I and my nice colleagues do workshops there, trainings, consulting, reviews, and also development. Besides this, I'm also quite connected to the Angular community. I live in Austria. I do a lot of stuff here in Germany. Actually, since 2008, I'm here on a bi-weekly basis. I'm traveling across the federal states and I'm helping companies with Angular in the enterprise. I always enjoyed it to discover all the little and bigger differences of the different regions here in Germany. And also, when I promise to behave well, sometimes people let me into other countries. Okay, so let's get started with hiding frameworks and versions. We want to abstract them away. And when it comes to abstracting away all those differences, in theory, we could use each and every abstraction. In theory, you could define your interface, or you could define there has to be a JavaScript file exporting a start and a stop function. A start function that is bootstrapping your single page application in the middle of our shell, and a stop function that is removing it. Of course, you could do this. However, here I'm going one step further. Here, I'm wrapping my single page applications, my micro frontends, into a web component. It's also an abstraction, and it's also a well-known standard. All of the frameworks out there, all of the browsers out there are supporting. This is not a typical web component. This is more a coarse-grained web component, but at the end of the day, it's fine, because also your huge application, your micro frontend, is a component. A component that consists of a lot of components that in turn consist of a lot of further components. So, in order to wrap something into a web component, the easiest thing you could do is to subclass HTML element, just extend from it, and then you get this connected callback method. You override it, and in there, all you need to do is bootstrapping your application. So that's it more or less. Instead of writing something into the DOM by yourself, in there you bootstrap your Angular application, your React application, your Vue application, and so on. And then you need to register this web component with your browser. For this, you can use these methods provided by the browser, custom elements define. The string you are passing in here is the name of an HTML tag. And every time you are adding such a tag to your shell, immediately your web component and so your micro frontend is displayed. And when you remove this tag, then also the web component and so the micro frontend is hidden. Of course, you can do this by hand, but meanwhile there are several tools for all of this. For instance, in the Angular space, we have Angular Elements, which is an official project by the Angular team, and it does this wrapping for you. You just need one line of code to get this web component wrapper. And you find open source tools for similar things in other spaces, like I've seen something like this in React, for instance. When you go one step further and expose this web component via federation, it looks like this. You just have this federation config, and in there you are exposing your file with the web components. You are assigning an alias because usually your consumer, your shell, is not interested into knowing the full path of your files. It's not interested into knowing that there is projects, mfe2, source, my web component. You just want to go with a short name. And after that, you can just load this web component into the shell via federation. So it's just a matter of a dynamic import. It's quite straightforward. You're using all the mapped names, the mapped name on your side, the mapped name over there, and that's it. And then, of course, you need to add an HTML tag so that your single page application, your micro frontend, is displayed. And usually you want to wrap those 3 lines of code up in a wrapper component you can activate via your router. Your React router, your Angular router, your Vue router. And of course, it would make sense to make this component a bit more generic. We don't want to hard code those strings here. Usually we have some parameters, some inputs, some properties for those strings. And so you have one nice simple component for loading everything from other frameworks and or other versions via federation. The good thing is, as you are using web components together with federation, you get the best of both worlds. You can use the same version and you can share it when the same version is used by several micro frontends. So here the shell and MFE1 is sharing Angular in version X. However, MFE2 and MFE3 needs another Angular version, Angular Y. Federation will find out at runtime and make sure this version is only downloaded once and shared across those micro frontends. And you can also go with other frameworks like React, for instance. So the best of both worlds. If it's possible, it's shared. If it's not possible, you bring your own version or framework. So let me show you a demonstration for all of this. Here I have a simple application. This application was built with Angular 14. This shows we are doing this style of architecture for quite a time now. And if we are loading here the first micro frontend, we see, well, this is also built with Angular 14, and so we don't need to download Angular one more time. Angular 14 is shared between those two independent applications. Here I'm loading a React application, and so of course React needs to be downloaded once, but only once in this version. If I had another micro frontend also using Angular 17, it's quite an old version, I'm very sorry, then it would be shared at runtime. Or look here, those three guys here are using Angular 12. And Angular 12 is shared here. It's only downloaded once, and then I just need to download the source code of the application. Here we have something special. That's fun. This Angular application has a router of its own. And now this brings some difficulties. Because usually a single page application assumes that the route, the URL up there, belongs fully to itself. It's like Louis XIV, who said, I am the state. Here the router is saying, I am the URL. That means we need to find a way, and you can do this in all the frameworks, to make sure that the router is only looking at a specific segment of the URL. So in there, this guy here is only allowed to look at the second segment, and this guy here is only allowed to look at this first segment here. That's a matter of configuration. By the way, as I don't want to make someone feel bad, I also have a Vue example included here, also here in older version, and I even have AngularJS. And I think this shows that this style of architecture is also good to migrate away from an older technology stack little by little, which happens quite a lot in the enterprise, where you have applications that last for decades. If you think about banks, insurances, they have to be maintained for decades. Here I have something that is a bit brutal. I call it the dashboard from hell. Dashboard from hell, because in order to run this dashboard, we have to load several frameworks, React and Angular and Vue and so on. Usually you want to avoid this. Perhaps you can share some data between your micro frontends, some data so that this dashboard, let's call it dashboard micro frontend, can build those styles by itself. What I really try to do is a vertical integration on the level of the main menu items here. Okay. So perhaps you're wondering, is this really that simple? And the answer is no. There are some workarounds needed to make it possible that several versions work together. Not big workarounds. Sometimes just 3 lines of code, and I have documented some of them here, so if you feel fancy, just look it up. So perhaps you're wondering, what are the alternatives? And yeah, there are some alternatives. For instance, you could go with one monolithic application, one big application several teams are contributing to. Then you don't have issues with version mismatches. However, you are trading in some team autonomy. When it comes to software architecture, it's always about trade-offs, isn't it? Or you could go with a mono repository and several micro frontends. Still, you can deploy them separately, but the mono repository makes sure you only have one version and no version conflicts. Or you could use governance, making sure with some tools that here and there and over there the same version is used. Of course, in all those cases you are trading in some team autonomy to get less issues with different versions. You could use hyperlinks. You could use iframes. I know iframes are not the most famous solution there. Or you could just go with web components. In all those cases, you have some trade-offs. For instance, if you just go with web components, you cannot share dependencies via federation. Here you see a screenshot from a monolith. One big application several teams contribute to. And here, usually, you want to make sure that one team is not using too much stuff of another team. Because if this team here changes something, you don't want that over there in the other team something is breaking. And you can do this via linting. So here, I'm in the ticketing space, in the ticketing domain. And this domain is supported by one team. And I want to grab over to the check-in domain of another team. And by configuration, the linter is telling me, hey, Manfred, hands off, you are not allowed to grab over there. And to do this, you can use different tools like NX or Sheriff. So if you are interested into this architectural style, then look them up. So last but not least, the big question is, what are the costs of this? And I think meanwhile, I found a currency for expressing those costs that is quite accurate and that is manager-proof. When you go with micro frontends, you have several teams, stream-aligned teams, that want to produce business values in their areas. And in addition to those teams, you need a little platform team, providing all those workarounds you might need, providing samples, providing guidelines, providing perhaps helper functions. I have seen companies with 80 teams, 80 and more stream-aligned teams working on their micro frontends, and they had just one simple, tiny micro frontend platform team with 3 or 4 people providing stuff as a service. That means they provide guidelines, examples, helper functions, and so on. So those are the costs of this architectural style. However, chances are you need some kind of platform team anyway when you have several stream-aligned teams contributing to the same software system. So if you like all those ideas, then please look up my free ebook here. It's meanwhile in the 6th edition, and we have 20 chapters about all of this and a lot more. Let me come to a conclusion. We have basically seen 3 things today. We have seen that web components allow you to abstract away the differences between frameworks and libraries. So you can mix and match different technologies. And we have also seen that using federation, native federation or module federation, allows you to load stuff from over there, stuff you did not know at compile time, and you can share dependencies when the same version is used. When you need a different version, then, of course, this different version is loaded on demand, lazily. And last but not least, very likely to succeed with this architectural style, you need a platform team, providing workarounds, providing guidelines and helper functions. Because the thing is, here, you are leaving the space of a default architecture and you have your own special architecture that might be necessary when several teams need to work together. And that's it. So here you find my contact data. I've already uploaded my examples and my slides to my blog. Please find everything here. And make sure to follow me on social media to stay in contact. Thank you.